This video covers the problems from the Unit 4 review. So this one begins with simplifying using I. So you may have something like the square root of negative 63. So when you have the negative square root, the first thing you need to do is separate into the square root of negative 3 times the square root of whatever the rest of the square root is, so positive 63. The square root of negative 1 is always I. And then we have to decide what's happening over here. It could be a perfect square. It might not be. So this one is not a perfect square. So I'm going to do a factor tree. So 2 will not go into 63. So I'm going to try 3. So 63 divided by 3 gives me 21. And that means I'm done with the 63. Then 21 can factor out to 3 and 7. So what that means is that the square root of positive 63 is the square root of 3 times 7. And we look if there's a pair, then we circle the pair. And since we have one pair, 1, 3 comes out of the square root box, and that 7 has to stay in. So then I come back over here, I times 3 square root of 7. And we generally write this in the format of 3i square root of 7. We definitely do not want that I underneath the square root box. So whether you put that in front of the square root box or behind it, it cannot be underneath it. On number 2, we have a binomial that includes an I and another binomial that includes an I. And there's no sign in between the parentheses, so we have to FOIL. So we're going to take 3 times 5 to get 15. And then 3 times negative 2i will give me negative 6i. I times 5 gives me plus 5i. And then I times negative 2i is negative 2i squared. So that is not simplified. I have to simplify that. So 15, there is no other term like that. But I have a negative 6i and a positive 5i. And so I need to combine those, which would give me negative I. And then I have negative 2i squared. I squared is, we can't leave that in an answer. So I squared is the same as just a negative 1. So when I go to write this down here, I'm going to do minus 2. But then instead of the I squared, it's being multiplied by negative 1. So then the next line would be 15. I don't think that's going to work. So the next line would be 15 minus I, and then the negative 2 times the negative 1 is positive 2. So then the I squared is completely gone. So I have 2 like terms. I have a 15 plus 2. So that gives me 17 and then minus I. And we generally put the real part first and then the complex part second. The complex part is the I. On number 3, we're still working with complex numbers because we have the I, but this time there is a minus sign in between the parentheses. So we have to make sure that we distribute this negative sign to the numbers in the second parenthesis. So I'm going to rewrite the first binomial without parentheses. So 5 plus 9i. And then I have negative 8 and negative 5i. And then I'm going to put like terms together. So I want the real part first. So I have positive 5 and negative 8. So negative 3. And then plus 9i minus 5i plus 4i. And again, we put the real part first and then the imaginary part. Okay, on number 4, you're given the graph of y equals x squared. And then you're also given another function, and maybe it's f of x equals x squared plus 8. So what this means is this 8 means that the graph has shifted vertically up 8. So when you're asked to describe the transformation, it should be worded something like this: shifted vertically up 8, shifted up 8, something like that. And then remember to find the vertex. You use the formula x equals negative b over 2a. So in number 5, you are given a function that is in vertex form, and you're asked for the vertex, the axis of symmetry, whether it's a max or a min, and what that value is, and the domain and the range. So remember, the vertex is always, now let me switch colors. The vertex is always this number in parentheses, except it's the opposite. So that would be positive 4. And then the number that's at the end. So the vertex would be 4, negative 22. Then the axis of symmetry is always x equals, and it's always the x of the vertex. So it would be x equals 4. This, without even graphing it, we should know that this is, this opens downward. And I know that it opens downward because of that negative sign. So if it opens downward, it has a maximum. And the maximum value is always the y value of the vertex. So y equals negative 22. The domain, this is just a rough sketch of what it looks like. Well, the domain of a parabola is always negative infinity to positive infinity. And the range is always the lowest y value, which, since this goes down forever, the lowest y value is negative infinity. And then the highest y value we already discovered over here was negative 22. So that might also look like this in Math Excel. Okay, so there are 2 ways that that can be written. So on number 6, you're given an equation that is in standard form, and you're asked the same questions that you were asked on number 5. So we have to find the vertex, we have to find the axis of symmetry, max or min, and range. Well, We can't do the vertex and the axis of symmetry yet. Now we could tell if it is a max or a min because since the equation is positive, I know that my parabola would open upward. So I know that I'm going to have a minimum. I just don't know what it's going to be yet. So we can put this into Desmos and find the vertex. You could also do the x equals negative b over 2a. And remember, this is the a, b, and c. So negative b would be negative 2 over 2 times, and then my a is an invisible 1. So negative 2 over 2. So my vertex, the x value is negative 1. And so the axis of symmetry is x equals negative 1. So at this point, you could get into Desmos to find it, or you could substitute this negative 1 into that equation to find the y. So I've done that here. I have used this blue equation, and I put the negative 1 in every time I saw a y, or I mean saw an x. So then if you do that in your calculator, you can use the parentheses just like I have. And the answer is 0. So that means that my vertex is negative 1, 0. And so now I remember I had a minimum, which is my y value of the vertex. So y equals 0. And then the range is always the lowest y, which now I know the lowest y is 0. To the highest y would be positive infinity. And again, in MathXL, it might look like 0 is less than x is less than positive infinity. I skipped number 7 because it's very much like number 6. You can use Desmos to find everything. So on number 8, though, it asks you to solve this equation using the quadratic formula. So my a is 1, b is negative 3, and c is negative 54. So when I use my quadratic formula, it is x equals negative b, and my b is negative 3, plus minus the square root of b, which is negative 3 squared, minus 4 times a is 1, times c is negative 54. And all of that is over 2 times a, which is 1. So then on my next line, x equals negative 3 is a positive 3, plus minus, and I'll figure out what all of that is, over 2. So to find out what goes under my square root box here, I'm going to put all of this in the calculator without using the square root button. And I want to make sure that I use all those parentheses. If you don't put the parentheses in, it's going to mess everything up. So I got 225. And now I'm going to check to see if 225 is a perfect square. And it is. So now my next line can be x equals 3 plus or minus, and the square root of 225 is 15. So now that I have found the square root, I don't need the square root box anymore. So then I take this kind of bluish color, and I'm going to split this into 2 equations over here. So I'm going to have x equals 3 plus 15 over 2, and x equals 3 minus 15 over 2. So this would be x equals 18 over 2, which simplifies to 9. And over here, x equals negative 12 over 2, and that reduces to negative 6. So those are my two solutions, 9 and negative 6. So on number 9, you are given an equation and asked to solve it. Well, we would like to have it equal 0 first. So I'm going to subtract 16x. And so I have 2x squared minus 16x equals 0. And I want to find the greatest common factor. So 2x will go into both of these. So 2x. And then 2x squared divided by 2x is x. Negative 16x divided by 2x is negative 8. And now I have two factors. One of them is 2x and one of them is x minus 8. I am going to set each of those equal to 0. So 2x equals 0 and x minus 8 equals 0. And I'm going to solve each of those for x. So divided by 2, x equals 0. And plus 8 on both sides of the equal sign. X equals 8. So my two solutions are 0 and 8. Number 10 is another quadratic formula. So I have x equals negative, and my b is 5, plus minus square root of b squared times 4 times a, which is 5, times c, which is 7. And all of that is over 2 times my a is 5. So then we're going to start simplifying. So x equals negative 5 plus minus square root of, and all that's going to be over 10. So in my calculator, I'm going to put parenthesis 5 parenthesis squared minus 4 times 5 times 7. And that is negative 115. So negative 115 is not a perfect square. So over to the side, I am going to deal with my square root of negative 115. I need to separate that out into square root of negative 1 times square root of positive 115. My square root of negative 1 is I. Now, 115 is not a perfect square, so I need to come over to the side. 2 will not go into 115, so I try 3. That doesn't work. So 115 divided by 5 is 23, which does not break down anymore. So the square root of positive 115 is just square root of positive 115. We can't break it down. So then when we simplify, we have x equals negative 5 plus minus, and instead of writing the square root of negative 115, we are writing I square root of positive 115. And so our two answers, because we can't reduce that anymore, our two solutions are going to be negative 5 plus I square root of 115 over 10 and negative 5 minus I square root 115 over 10. On number 11, you are given a quadratic equation, but you're only asked for the discriminant. Well, the discriminant, if you remember, is just b squared minus 4ac, which that is what was underneath the square root box when we did the quadratic formula. So I'll just work down the page here. B squared, so my b is 6. So 6 squared minus 4 times a is 4, and c is 5. So then if we put all of that in our calculator, 6 squared minus 4 times 5, it is negative 44. So the discriminant equals negative 44. And then you might be asked a question like, how many real zeros are there? I think I spelled discriminant wrong. Number of real solutions would be 0. There are none, because when you have a negative discriminant, you are not going to have any real solutions, because your answer would have an I in it. Number 12 is just like number 11. You're asked to find the discriminant, which is b squared minus 4ac. So my b here is 4, so 4 squared minus 4 times a is 4 times c is 5. So if I put that in my calculator, 4 squared minus 4 times 5, I get negative 64. So the discriminant is negative 64. And again, you may be asked the number of real solutions, which, because the discriminant is negative, there would be 0 real solutions.